Hello, this is Team Motor 9000. This is our motor that we cut of 0.35-inch acrylic that we found on the OEDK. Originally we designed it in SolidWorks, and then after laser cutting it we milled these slots for the magnet that are sized to be a friction fit for each magnet on each side.
So we also have a feature that is we can move the position of the magnet so that we can have an adjustable magnetic field so that we can find a sweet spot that can give us the largest RPM. Meanwhile, we also have some very interesting design features. For example, we know we are going to the fastest speed, so we want to decrease our friction as much as possible. That's why we ordered two high precision, high speed bearing, and they are working really well.
Yeah, so we spec those off of McMaster by looking up the highest rated bearing, which ended up being pretty small ones, along with this 1/8-inch shaft. Yeah, and to adjust the magnetic field, all you have to do is just turn these screws in and out, and it'll slide the magnets closer or farther away than the armature.
Also, another innovative design we used is that we chose to use a solder wick for our brush. This is very different from other popular choices like graphite or paints, but we figured out this is actually very good material. It has a very small friction and very good connectivity.
Yep. Additionally, we choose to use not too many windings because we weren't going for torque, and just use little zip ties to keep them together along with our laser cut and drilled out armature that we use. I think the final feature we have is we included some reflective tape so that we can use an optical tachometer to read the RPM or the speed of the motor without adding any extra friction to the system that a mechanical tachometer would use.
Also, one interesting design feature, it's not necessarily related to mechatronics. We decided to go with red and green wires to feature a sense of Christmas. We are calling our motor Christmas 9000.
Very festive.